Good morning, ma'am. I'm Rikin Gupta from First Year Petroleum Branch. My roll number is 19BPE109. My allotted topic is Introduction to Distillation in the Perspective of Refining. Now, what is distillation? Distillation is the process of separating the components or substances from a liquid mixture by using selective boiling and condensation. Distillation may result in essentially complete separation, nearly pure components, or it may be a partial separation that increases the concentration of selected components in the mixture. In either case, the process exploits differences in the relative volatility of the mixture's components. In industrial chemistry, distillation is a unit operation of practical universal importance, but it is a physical separation process, not a chemical reaction. Applications of distillation in petroleum industry. In the petroleum industry, oil stabilization is a form of partial distillation that reduces the vapor pressure of crude oil, thereby making it safe for storage and transport, as well as reducing the atmospheric emissions of volatile hydrocarbons. In midstream operations at oil refineries, fractional distillation is a major class of operation for transforming crude oil into fuels and chemical feedstocks. Types of distillation process. Some important types of distillation include simple distillation, fractional distillation, steam distillation, vacuum distillation, air sensitive vacuum distillation, short path distillation, and zone distillation. The petroleum industry. Now, there are four steps represented in this diagram. So, crude oil distillation is also known as fractionation. The first step in the refining process is the separation of crude oil into various fractions or straight run curds by distillation in atmospheric distillation column. The main fraction or curds obtained have specific boiling point ranges and can be classified in order of decreasing volatility into gases, light distillates, middle distillates, gas oils, and residue. The following is a brief of atmospheric distillation tower. The desalted crude feedstock is first created using recovered process heat. The feedstock is then sent to a direct fired crude charge heater, where it is fed into the vertical distillation column just above the bottom. Here, the pressures are slightly above atmospheric and temperatures range from 650 to 700 Fahrenheit. Any heating of crude oil above these temperatures can cause undesirable thermal cracking. All but the heaviest fractions flash into vapor. As the hot vapor rises in the tower, temperatures are reduced via cooling by natural convection. Heavy fuel oil or asphalt residue is taken from the bottom at successfully higher points on the tower. The various major products, including lubricating oil, heating oil, kerosene, gasoline, and uncondensed gases, are captured. The fractionating tower is essentially a steel cylinder that is typically about 120 feet tall. Inside the shell are horizontal steel trays that are used for separating and collecting the various liquid curds. At each tray, vapors from below enter through perforations and bubble caps. They permit the vapors to bubble through the liquid on the tray, causing some condensation on the temperature of the tray. An overflow pipe drains the condensed liquid from each tray back to the tray below, where the high temperatures causes re-evaporation. The diagram above presents a stylized version of the distillation process. Crude oil is made up of a mixture of hydrocarbons, and the distillation process aims to separate this crude oil into broad categories of its component hydrocarbons or fractions. Crude oil is first heated and then put into a distillation column, also known as a still, where different products boil off and are recovered at different temperatures. Lighter products such as butane and other liquid petroleum gases, LPG gases, gasoline, blending components, and naphtha are recovered at the lowest temperatures. Methanol products include jet fuel, kerosene, and distillates, such as home heating oil and diesel fuel. The heaviest products, such as residual fuel, are recovered at temperatures sometimes over 1000 degrees Fahrenheit. Thank you.